Hello, everybody. I'm Mecca. This is Nihar, and behind the phone is Mateus, and we are a part of Team 2105, along with Alan, who's currently at home processing the data of our experiment. So basically, the setup we have of our experiment is we have these three routers, and they're all connected to one another via AI mesh. And the phone Nihar is holding is sniffing the data from the routers. And basically our goal is to determine the pose of the phone in space. And now we're gonna take it to Alan to give a breakdown of the processing of the data.
Hi guys, so my name is Alan. I'm going to be talking us through the data preprocessing steps in machine learning to further analyze our data set. So once we finish our data collection process, we will receive our data set off the routers in the form of a PCAP file. These PCAP files will then be converted into MATLAB files so we can run a script provided by our sponsors Merle. This script helps us extract information we need from the packets, like the signal to noise ratio from each of the subcarriers. Then we will organize everything together in a CSV file for labeling. So here on the first column is a total of 15 different labels covering 5 locations and 3 poses per location. Then we have the next 208 columns for each of the non-zero signal to noise ratios from the subcarriers. Now with this CSV file, we are ready to move on to machine learning. For machine learning, we are using Python and Jupyter Notebook running the sklearn library. sklearn provides a quick way to get started with machine learning with their extensive guides and documentation. Here we will be using the classification algorithms such as support vector machines, nearest neighbors, and random forests.
And we're back. So if you take a look at Nihar, he's in a different position within the room as well as holding the phone in a different pose. And the reason why we're doing this is because we want to get multiple data sets in different localization situations within an environment so that we can train the machine learning algorithm, which Alan is processing the data of, to basically be more accurate.
So here is our preliminary results for our position and pose detection dataset. This is in the form of a confusion matrix. The rows on the left side represent the true labels for the position and pose, and the columns represent the predicted labels from our machine learning algorithm. So let's look at the true labels for position 1, pose 1. So here the machine learning algorithm correctly predicts that it's position 1, pose 1 correctly 28 times, but then it proceeds to mispredict it as pose 2 520 times. So we want all of our data points to reside in the cells in green going down this diagonal. This diagonal represents that for every prediction, it actually matches up with the true labels. And then here in the orange background cells, this actually means that the machine learning algorithm correctly predicts the position. So overall, using the random forest algorithm, we achieved a 24.3% accuracy for both the position and pose, and 38.2% accuracy with only detecting the correct positions. So looking down the diagonal, it seems like at positions 4 and 5, there's a lot of mispredictions, but then looking at positions 2 in pose 1 and positions 3 in pose 1, we have a high amount of packets that were correctly predicted. This is very promising. So looking at positions 4 and 5 closely, we went back to the drawing board of our three-step process of data collection, data preprocessing, and machine learning. So we went back to regather some data for positions 3, 4, and 5, and we are taking a closer look with other machine learning algorithms. So here we have random forests, support vector machines, k-nearest neighbors, and their respective accuracies at 49.7, 53.3, and 57.5% accuracy for both the position and pose. So here we can see k-nearest neighbors wins out at 57.5% and 65.3% for only the location based. So looking at positions 3 and pose 3 and positions 5 and pose 3, we can see that all of the values are accurately predicted and there were no mispredictions. This is very promising.
One. So what are the use cases for this?
So things such as security or localization, detecting, an object in space. What do you think, Nihar?
Well, another use case could potentially be if you're in a supermarket and the owner wants to see how traffic moves inside the supermarket from one section to another. Say you're buying bread, where are your customers heading to next? Maybe the dairy section. So this is something you can track using Wi-Fi localization.
Awesome, awesome. And this is just like the research part of this. There's a lot of stuff we can put to, like, if we expand on this research, and in like 2 or 3 years we could make this into a bigger product. But right now this is just the research space. That's awesome.